Okay guys, so the last part of today is systems of equations, solving them by graphing. That's why we've been doing so much graphing. Basically, all you have to do is plot both equations onto the same graph and see if they intersect. So, okay, we're going to plot this one first. Here, since there's no b value, we're going to start at 0. We're going to move according to the slope. The slope's -2, so go down 2 over 1. Down 2 over 1. And you want to make it as accurate as possible, so you need to continue the line. Okay, or if you use a straight edge, you need to at least do that. So there is the graph of the first line. So again, you plot the first one, then you plot the second one. So again, we're going to start here at +3 and up 1 over 1, up 1 over 1. So up 1 over 1. Now you can see continue to go up, but when we go downward and go the other direction, just to kind of keep the line going, the two lines are going to intersect. So when they intersect, guys, we say that this is one solution, and you give the coordinate point. At what point do the two lines intersect? They intersect at point -1, 2. Okay? And don't worry about this whole comparing thing. So let's recall here. Again, this isn't the first time you've done these systems of equations, but by graphing, all your goal is to try to graph both. So it says an ordered pair that makes a linear equation clue is called a solution. Okay, so like there, they intersected, we call it one solution. The point that the two lines intersect, again, just reiterating that, is the solution to the system. To solve a system of linear equation, the ordered pair must work for both equations. So you should be able to plug the two numbers in to both equations and it work. So basically, your ultimate goal is just make sure you can graph. If you can graph, you should be okay. So that's why we were practicing graphing so much. So let's take a look. Only a couple examples of these and then a few for you to try. Okay? So here, start here. Remember, if there's nothing there, start at 0. Then I'm going to go up 2 over 1, up 2 over 1, up 2 over 1. Please keep the line going. Just now do the reverse pattern. Always go to the right first, and then as you keep the line going, then go to the left. So there's the first line. Now I'm going to do the second line. I'm going to start at +3, 1, 2, 3, and I'm going to go, the slope is -1, there's a negative sign, so I'm going to go down 1 over 1, down 1 over 1, down 1 over 1. And you can see right away, that's good enough. There is one solution to this, and the coordinate point that is the solution is x is 1, and it looks like y is 2. And there you go. So just graphing the lines. So turn it over. Just a few more examples to make sure we're on the same page here. So again, now the only issue is, remember, this isn't in y equals form, so let's move this x over to here. So on the right side, it's going to be a positive 2x, because to move it, the opposite of negative is positive. That's why we were practicing that. So y equals 2x minus 4. This is what I'm going to graph. So I'm going to start at -4. So 1, 2, 3, 4 on the y-axis, and then up 2 over 1. Up 2 over 1, and then keep the pattern going. So you can see the slope there. Then here, now I'm going to do the second equation. I'm going to start at -2 and go up 1 over 1. So they almost hit there because the slope's 1 here, guys, but they're never going to write that. Up 1 over 1, up 1 over 1. So you can see already, I don't really have to make the line that long because I can see that they cross right here. So this is one solution. And the coordinate point, x is 2, y is 0 on the x-axis. So the coordinate point is 2, 0. So you can see, guys, it's basic stuff. I mean, it's just going to review and, kind of remembering what you have done before in the past. So let's take a look at 3 more examples, and then I want you to try just a couple. So, okay, we're going to start at +5. So just graphing each line separately, seeing if they intersect. This, down 1 over 1, down 1 over 1. Down 1 over 1. So I'm graphing the first line. Okay? And then now I'm going to graph the second line. So here's up 1, and then the slope is +1. So up 1 over 1, up 1 over 1, And you can see at that point I could probably stop because this is one solution, meaning the two lines do intersect at one spot, and I get 2, 3. Please make sure you list which of the solution is. Okay, let's do the next one. So I'm going to start at +3, and then the slope is 2, so up 2 over 1, up 2 over 1. Okay, 3 points is okay. Maybe I'll go just continue it a little bit further. Now some of you probably have already picked up based on the two equations. That's the first equation, and you notice that the slopes are the same. We've already talked about that. Parallel lines have the same slope. So like even if I start and I graph -4, right? And I go up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1, these lines are never going to intersect. That's why they're parallel. So when you see that the two lines never intersect, you write no solution. Okay, and we're going to talk about what that looks like as we solve with elimination next class, how it'll look, okay? Most of you probably remember though. Now for this one, it looks like you have to change both of them to y equals form, so all I'm going to do is subtract the 2 here for the top one and bring it over. So I'm going to rewrite the top equation as y equals -2x plus the 2 that was there. So again, on the left side of that equation, it was a +2. When I move it to the right, it becomes a -2. So I'm going to plot this line first. So I'm going to plot 2 and then down 2 over 1, down 2 over 1, down 2 over 1. Okay, so I've got this right here. Then, let's see, I'm going to divide to get the y by itself. Don't add 2. This is multiplying by -2. So I'm going to divide by -2. So I get y equals -2x plus 2. Well, clearly, guys, you can see here, they're the same. They're the same line. So even if you graphed one on top of each other, they're going to be touching every single point. This is that example of infinitely many solutions. So that means they have every point in common. Okay, obviously it's right on top of it, so it's going to have everything in common. So those are the 3 scenarios, guys. You one solution, no solution, infinitely many, that you'll get when you solve systems of equations. The elimination we just did, and we had all one solutions. We'll talk about that algebraically, but graphically, get used to these 2. So give the 4 practice problems a shot, and then I'll have the last video there that'll show me going over them, and then from there you can start your homework. So try the last 4 of this packet. Looks like this.